Hello, my name is Carlos Rodriguez, and today we'll be discussing infrared wavelength filtering for security cameras. I'd like to begin by describing how a camera takes a light source and converts it into a digital image. The process begins by focusing the external light through the lens. The focused light is then passed through an infrared filter and then various color filters. These filters work similar to how a pair of sunglasses would work. Each of these filters is coated in a thin film that absorbs a different part of either the visible light spectrum or the infrared light spectrum. After filtering out the infrared light and some of the other colors depending on the monitoring environment, the light gets reflected off of a mirror and into the charge-coupled device. The charge-coupled device then creates a series of charges based on the light it receives and sends these charges to the processor. The processor then applies a series of algorithms to reconstruct the image as seen by the charge-coupled device. The charge-coupled device inside the camera is etched into silicon. Because the charge-coupled device is created on silicon, it shares the same physical properties. The absorption coefficient graph shows data taken by Dr. Martin Green back in 2008. The graph shows that silicon effectively absorbs wavelengths between 300 nanometers and 1100 nanometers. Comparing the graph to the figure on the right, we find that silicon absorbs all of the visible light spectrum, but also absorbs some of the near-infrared light. This means that cameras incorporating silicon charge-coupled devices are susceptible to infrared interference. This is an example of one way infrared light can interfere with security cameras. This example shows the infrared light blinding the camera and obscuring the face of the person. While silicon may be an inexpensive material to create the charge-coupled devices on and mass-produce, it has its drawbacks. By applying filters, you can limit the amount of interference you receive from unwanted light sources. Another option would be to change the material the charge-coupled device is etched onto, making sure that this new material has a small wavelength absorption range while still including the visible light spectrum. Thanks for watching.